is handling the camera. We'll move on to number 10. Identify the charge on an ion when electrons are lost or gained. Okay, ion loses 1 electron. What's its charge?
It loses 1 electron?
Yes.
It would be +1.
+1. Ion loses 4 electrons. What's its charge?
Is it +4?
Ion gains 2.
-2.
Awesome.
There you go.
Pretty simple.
And that goes back to elementary school math.
Right.
You
We're
can do
a bit
that.
way done already.
You can, yeah. Number 11, write an electron configuration of a specific ion.
You're getting good at this.
Didn't,
You're going to know that half of the chapter like so well.
yeah,
next time we're done.
didn't we do that in the last chapter?
Yeah.
Did we do that in the chapter before that?
Maybe a little bit.
Yeah,
Yeah.
a little bit.
So
Okay.
again, look at how many electrons it needs to add or gain. The thing that might be a little bit different in these answer choices is they'll say, instead of giving you the correct configuration or an incorrect one, they might say, oh, this will have the configuration of argon.
Right.
Well, if it's going to a noble gas, that could well be the correct answer. Make sure you're looking at an element that's close to that particular noble gas, because these atoms are trying to end with a noble gas configuration to get that octet to have their highest energy level filled.
Right.
Number 12.
What occurs in the formation of an ionic bond?
Why do atoms want a bond?
Yeah, that was good. Remember back from the movie and things we've done in class, you have this transfer of electrons creating oppositely charged ions, and they're attracted to each other.
So you said transfer of electrons. What atom wants to give up the electrons?
That would be losing electrons.
Yeah.
Left as losers. Metals are electron losers.
Right, so a metal is going to give up its valence electrons or lose them, and they're not just going to go willy-nilly off into space somewhere, hang out at the electron club. They're going to go to a non-metal nearby that is going to receive or gain those valence electrons.
There you
Okay. Number 13. Identify the net charge of a specific ionically bonded compound. The net charge. Those little words are the important words. When 2 elements bond ionically, we have a metal transferring valence electrons to a non-metal. And the overall charge of the whole compound,
Once they stick together,
once they stick together,
neutral. It is
Neutral.
0.
right.
0.
The positives cancel the negatives. That's why they go together in the particular order that we do. NaCl, sodium loses 1 valence electron, chlorine gains 1, positive 1 and a negative 1, add together to get 0.
Well, what if the charges don't match though? What if you have a positive 3 ion combining with a negative 1 ion?
Well, then you just need more of that other
okay.
ion. I don't know if we have the magnets handy, but you're saying, what if we had a positive 3 charge, like for aluminum, and, okay,
And then you had a negative 1 ion. Well, clearly the charges are not balanced. The net charge is not 0.
so one of each is not going to be enough, because we see aluminum's got more spots there. 2 isn't going to work, but
Yeah.
we could have 3 chlorines. They're each -1, -1, -2, -3. We have all 3 of them together will cancel the charge.
Sure.
Okay, so we just work it out like that. That's a nice preview of our formula writing
Yeah.
chapter.
The formulas for an ionic compound always give you the recipe for a neutral compound.
Right.
Always do. Number 14, identify the common name for ionically bonded compounds.
I love this on my French fries.
Okay, go.
Salt.
Yes.
Not just table salt.
No. Any kind of ionic compound. There happens to be one particular salt that is so super famous
Right.
that we just refer to it as salt. But any ionic compound,
Any and all.
yes.
So here's a salt. It's a giant salt crystal, but this one isn't cube-shaped like sodium chloride. This is actually calcite, calcium chloride.
It's kind of a rhombus.
It is. A little bit.
Yes.
Alrighty. Where are we?
15.
15?
Yes.
Identify a pair of atoms that would likely form an ionic bond. Boy, do you have choices here. You have all of the metals on one side of the zigzag line on the table versus all of the nonmetals, not the noble gases, we know that, over here on this side. So pick an element from over here somewhere and one from over here in the upper right corner. Those metal and a nonmetal will make an ionic bond. It's kind of like playing concentration, but you got lots and lots of ways to win.
Yeah, pick something that wants to lose electrons, pick something that wants to gain electrons. And there you go.
Pretty easy.
Yeah. Number 16, identify which state ionic compounds are in at room temperature.
Ohio?
Well, for us they are. For Bergman and Sam's, it's
Colorado.
But if you remember way back to the first lab that we did, we had ionic compounds were solids. They're always solids. They're held together with really strong bonds, which lock them into that, what was that, that weird vocab word, that crystal lattice?
Structure, yeah.
And that keeps them solid at room temperature.
Okay, and remember, the sodium chloride back in the first lab of this chapter was the substance that did not melt. One of the two substances that did not melt when we put it on the hot plate for 10-15 minutes or so. Okay? Number 17, identify and describe the melting point of an ionic compound. Well, funny that I just mentioned that. The sodium chloride, the salt, did not melt. Our hot plates did not get hot enough for that. And if you remember the World of Chemistry video, which is posted on Moodle, that you can go back and look at again, the demonstrator
Don Showalter
had to heat that really hot to get that substance to melt. You have to break a lot of bonds in an ionic crystal. There's that electrostatic attraction in every direction around each ion. So it's not just breaking one bond. You got to break really 6 bonds around any given atom in an ionic crystal, and that takes a lot of heat energy. So ionic solids have very high melting points. That's one of their characteristics. Number 18.
Number 18, identify when an ionic compound can conduct electricity. And again, going back to that video series demonstrator, Don Showalter took those crucibles and he heated 2 white crystalline solids until the point where they became liquidy. They were molten, I think was the word, and one of them lit. The bulb is lit. And ionic compounds will conduct electricity when they are molten or when they are dissolved in water. And we did that lab as well.
Right. We did a conductivity lab with the little Flynn conductivity testers, and you had the little vials, and all of those solutions where the light bulb did come on, those had salts dissolved in them. We actually, when a salt dissolves, it does break apart those bonds, those attractions between the ions, and then we have all these charged particles that can float around in there, that move, that can carry a charge, carry an electric current.
And they can't do that in the solid state because they're locked in that crystal lattice.
Right.
Number 19, identify characteristics of ionic compounds. Well, we just went over a couple. They're solids at room temperature.
Right.
They have incredibly high melting points and boiling points.
They conduct electricity if
they are molten in the liquid state or dissolved in water, some sort of solvent. I don't know if they would dissolve if
in other solvents. Well, they tend to dissolve in water. I think some of them can dissolve, at least partially, in some other solvents.
So, what else?
Crystalline structure, high melting boiling point, conduct electricity. I think we're good.
Yeah, that's about it. Number 20.
Describe a metallic bond. We've got a couple pictures of this posted on Moodle. Here we're talking about the sea of valence electrons, because now these d electrons can get involved in the whole process. And those d electrons, because all these are metals in here, can break free from the atom they're originally attached to and float around in between all of the atoms lined up. The picture is going to be a great reference for you.
What was that phrase?
The sea of delocalized electrons,
Yes.
the mobile electrons.